Alright, this is a video of the 3 proofs on the Chapter 3 review. I will do my best to get them all done in 15 minutes. Number 12, there's a circle with the center at P. There is the midpoint E. And we want to prove that triangle PEO is congruent to triangle PER. So the 2 columns have to be set up like this, the statement here and the reason here. And the first statement is the circle with the center at P, and that is given to us. And then I am going to draw PE first. And the reason is 2 points make a segment. So we'll draw PE in there. And the third one is that PR is congruent to PO. And that is all radii are congruent. That's this segment and this segment. And then the fourth one, I'm going to put the given in there before I use the midpoint. So the midpoint, E is the midpoint, E is the midpoint, all right, of RO. So 4 is given, and then we say 5 is RE is congruent to OE. That's because midpoints create congruent segments. Midpoints create congruent segments. Number 6, the reflexive side, PE is congruent to PE, and that is reflexive. Okay, and then 7 is that triangle PEO is congruent. We got the reflexive side, we got the median side or midpoint side, and then we have the radii. So we have PEO congruent to triangle PER, and that is by side, side, side. And the first side is 3, and 5 and 6 are the other ones. Okay, awesome and awesome. So that's that proof, right? And the second proof is given angle A is congruent to angle D. Looks like an isosceles triangle here. We're not sure, but we got to figure that out. AC is congruent to DB, so we have this segment here congruent to this segment here. And we want to prove that this segment is congruent to this segment here. So it's likely we're going to get these triangles congruent right here and right here. Okay, so these are the segments that we have to get congruent, and we will probably use CPCTC. All right, it looks like a subtraction problem here. If I subtract BC from this segment and from this segment, it looks like I'm going to get these two. Okay, so let's lay it out. Statement reason. So angle A is congruent to angle D. That's given. Now, we know that these are base angles of the triangle, ASD. So we also know that this big triangle, ASD, is now an isosceles triangle. So we can say that. Okay, triangle ASD is isosceles. And so that's base angles. Base angles congruent. Now, because it's isosceles, AS and DS are congruent. So AS congruent to DS. And that is because if isosceles, 2 sides congruent, 2 legs congruent. Okay? So we have the 2 sides. Now, let's say we have to get this last given in here, this AC and DB. So AC congruent to DB, and that's given. extend that T-bar. That's given to us, and it looks like AB is congruent to DC, and that is subtraction. Subtraction, and in parentheses I can put of BC, because BC is subtracted from these two big ones here, right, to get these two segments here. All right, so now we have, looks like side angle side for the two triangles. Okay, so for step 6, triangle A, is that a, what's on top there? I forgot. ASB, congruent to triangle DSC, and that is side angle side. Right, the first side is the step 3. The angle is 1, and the other side is the 5, the subtraction one. So that gives us SB and SC congruent by CPCDC. SB congruent to, what was it? SD. SB is congruent to SC. And that is CPCDC. Corresponding parts of congruent triangles are congruent. All right, last proof. Okay, last proof, we have AED, so this triangle here is congruent to, or this segment is congruent to BE. Okay, so and ABF is isosceles, so that means that this segment is congruent to this segment, and then this angle is congruent to this angle. And we need to prove this segment is congruent to this segment. So if you don't see it already, if we can get this triangle to be isosceles, we got it. So if we can get this angle here congruent to this angle here, we can get the sides congruent. Because if the base angles are congruent, then the sides are congruent. Okay, and vice versa, like we did in this proof up here. So we have, if the base angles are congruent, which we have here, the sides are congruent. Opposite sides. Okay, so let's do it. All right, it looks like overlapping triangles. So let's take them out. Looks like this triangle here, which is this one, all right, which is AEB. And the other triangle looks like, I bet you it's this one, all right, which is ABD. Now we're given AD is congruent to BE. So we're given this segment congruent to this segment. Okay. Now, if you notice, this angle right here is angle BAC, which is right here. Okay. Is congruent to this angle here because of isosceles here. And that is this angle right here. See? All right. And if you don't notice already, we have the reflexive side. All right, so we can get the triangles congruent by side angle side. We got to do it. Let's do it. And then we're going to say something about isosceles. Okay. So I can't quite see the time. I got to watch it. All right, we get that. All right, so I just had to watch the. I can put my glasses on for a minute. All right, so let's do it. We've got a 2-column proof here, and we'll go ahead and do it in black. So this is the statement, and this is the reason. We have AD is congruent to BE, and that is given. All right, and then we have number 2. We have ABF is isosceles. Triangle ABF is isosceles. That's 2. And that's also given. So from that, this angle is congruent to this angle. So angle DAB angle DAB is congruent to angle DAB is congruent to angle EBA. Right, that's this one, EBA. So DAB is congruent to EBA. And that is because if isosceles, okay, base angle is congruent. Number 4. Number 4 is, well, let's see. We got AB is congruent to BA. So AB congruent to BA. And that's reflexive. The overlapping part. So we have the triangles congruent now, looks like. We have this, we have the triangles congruent by side angle side. Alright, so 5 is triangle, and I'll just steal the 3 letters up here. Triangle DAB is congruent to triangle EBA. That's a triangle. And that's side angle side. And the first side is 1. The angle is 3. And the other side is 4. Now, if we can now say that these big angles, okay, so this big angle right here is angle BAE, which is this angle here, right? And then the other angle is angle DBA, which is right here. If we can get those 2 angles congruent, we have an isosceles triangle. So we need to say that. So BAE, angle BAE is congruent to triangle ABE, I think. BAE. Oh, nope, it's not BAE. I should shrink this a little bit. That would help. I saw it. It's not angle BAE. It's angle DBA. Is congruent to angle AE. What is it? Letter there. AEB. And that is CPCTC. All right, and so we are done. It's AC congruent to BC. And that is if base angles congruent, sides congruent. It's kind of like the angles, then the sides. Alright, there's the proofs. Have a good weekend. Miss you guys. I'm doing my best, okay? As I always do. So I hope that made a little sense and